Okay, last time what we had studied was various types of intelligent agents. A simple reflex agent, what it is. We talked about what is the real architecture of that kind of agent, simple reflex agent. Uses action only based on the current percept. So whatever information is coming right now, it will just work on that. Then you have something called a model-based agent. These agents have the model, which is the knowledge of the world, and based on the model, they perform action. They just find out the what is the state right now, and accordingly, they will perform action. Then we have goal-based agent, wherein goal is very important. huh? Knowing something about the current state of the environment is not always enough to decide what to do. So here, goal is in focus. The agent also needs some sort of goal information. So in goal-based agent, that is how it is different. You have a utility-based agent. These agents are similar to goal-based agent, but provide an extra component of utility measurement. Okay, which turns them different from providing a measure of success at a given rate, given state. Okay, utility-based agents are only useful when there are multiple possible alternatives, and an agent has to choose in order to perform the best action. Then we have learning agents. Learning agents are the type of agents which can learn from the past experience, and it has learning capabilities. It starts to act on basic knowledge, and then is able to act and adapt automatically through learning. Okay. So these are the 5 types of the models that we had looked at. Okay. So we are talking about artificial intelligence. So here, humans, it seems, know things. They collect information from the environment over past experience, and what they know helps them do things, isn't it? And these are not empty statements. They make strong claims about what intelligence of humans is achieved by purely reflex mechanism, but by processing of reason. So there is something called a reasoning that operates in behind, isn't it? And so that is what is in reasoning, which taps into the knowledge of a person. Okay, so internal representation of the knowledge is there, which we will have to look into, isn't it? If you're talking about AI. In AI, this approach to intelligence is embodied in the knowledge based agents. So, what is reasoning and logic? So, reasoning is a set of process that enables us to provide basis for judgment, making decision, and even prediction. Okay. So, there is something called inductive reasoning and deductive reasoning. What is inductive reasoning? You have a basket full of grapes. Now, if you want to just want to buy grapes, now you want to know which grapes are really uh, sweet. So what do? You just pick up 2 grapes and taste and see whether this bunch of grapes is tasty or not, okay, or sweet or not. You take 2 or 3 samples and eat and see whether it is so. And what do you come to an inference? You say that okay, now this bunch of grapes is tasty, so I'll just buy this bunch of grapes. Hmm? तो एक अनुमान लगा रहे हो आप. You're just inferences, एक अंदाजा लगा रहे हो, है ना? So this is what is inductive reasoning. What is inference? Inference itself means you are making a एक अनुमान जो होता है ना, एक वो लगा रहे हैं आप किसी चीज का. तो there are certain facts known to you, and accordingly we are going ahead and taking certain decisions, concluding certain things. So what is the first statement? Suppose कीजिए कि it is something like mango is a fruit is the first statement, and the second statement is the box is full of fruits. So now, can you conclude that the box is full of mangoes? Can you say that? What was the first statement? Mango is a fruit. Second statement is the box is full of fruits. Can you conclude that the box is full of mangoes? No, isn't it? Cannot do that. So inductive reasoning that you go about may not be true always. Okay. In deductive reasoning, so in inductive reasoning, what we do is we start with a specific observation. We take two grapes from a bunch of grapes and decide and एक अनुमान लगा रहे हो, एक inference निकाल रहे हो कि हाँ ये bunch of grapes are sweet. What is deductive reasoning? We start with a general statement and examine the possibility to reach a specific logical statements. Okay, so we what we do is something like first statement is all the mangoes are fruits. All mangoes are fruits. The second statement is all fruits are have seeds. Okay, all mangoes are fruits and all fruits have seeds. Now, what is the conclusion that you have drawn? Mangoes have seeds. Okay, so that is always true. Huh? All mangoes are fruits and all fruits have seeds. Then what is the conclusion you're drawing is mangoes have seeds. Okay, so this is an example of deductive reasoning. So what are we starting with? A general statement. All mangoes are fruits. We are starting with a general statement. और पहले वाले में क्या था inductive reasoning में? We said a mango is a fruit. That was our first statement. Mango is a fruit. Is a you're starting from a specific observation, है ना? Specific mango you are picking. The mango is a fruit. So a specific observation, and now we are wanting to conclude something like something bigger. This box is full of mangoes. Okay. So inductive reasoning, we start with specific observation, and in deductive reasoning, we start with more general statements and examining the possibility to reach a specific logical conclusion. So even if all the premises are true in a statement, inductive reasoning allows for conclusions to be false. That we saw. Mango is a fruit. Box is full of fruits. Conclusion ये निकाल रहे हैं. The box is full of mangoes. The box can be full of fruits like apple, bananas, grapes. No? So we cannot conclude that the box is full of mangoes. Deductive reasoning, if something is true for a class of things, complete class of fruits, you are saying something, कि सभी fruits में seeds हैं, general, it is also true for a particular member. So it is also true for mango. Okay. So an example over here we are taking for inductive reasoning is Mona is a teacher. Mona is studious. Therefore, we can say that all teachers are studious. So for a particular person, we are taking an observation. Specific person, Mona is a teacher. And then we go ahead and generalize that all teachers are studious. So we are going from something called a specific observation to a broader general statement. And if I take this example, that all women of age above 60 are grandmothers. Reena is 65 years, therefore Reena is a grandmother. So we are starting with a general statement. All women above 60 are grandmothers. Okay, we start from the general statement. For a particular person observation, we are seeing whether it's true. So Rima is 65 years, therefore what we are concluding is that Rima is a grandmother. Okay. Now here, reasoning and okay, so this we talked about reasoning and what is logic. There is a universal agreement as to the exact definition and boundaries of logic. What are they? Logic consists of following. There is no universal. They are saying there is no universal agreement on the difference of logic. What are we saying here over here is logic consists of following a formal system and a proof theory. Okay, a formal system में क्या है? What is the proof theory talking about? Okay, I've written over here. ये proof theory क्या है जो कि हम लोग mathematics में logic में use कर सकते हैं. तो proof theory is a branch of mathematical logic that represents proofs as formal mathematical objects and facilitate their analysis by mathematical techniques. That is what is a proof theory. Uh, uh, so logic consists of the following. So what is a formal system? Formal system for formal system of describing certain affairs. Okay, so we have certain syntax, we have certain semantics. Okay, A is equal to B, so A and B are the same, something like that. Okay, so it consists of the syntax of a language. So there is a formal system wherein it consists of syntax of a language and it has certain meaning, a semantic to that language. So the syntax describes how to make the sentence, how do you design the sentence, and semantics is how do you attach meaning to the words. What are actually the meanings to those words? So two kinds of logic we look at is prepositional or Boolean logic and first order logic. Okay, these are the two kinds of logic. Now in this AI, you have this Wumpus world example given in your book also, and it is quite a famous this thing. So what I want you, I'll not to spend the time over here. You can just go through this you video to see the Wumpus world problem. इसमें कुछ नहीं है, एक कुछ मैट्रिक्स है, मतलब एक कुछ ऐसी जगह है जहाँ की एक Wumpus is nothing but a demon you can say, and you are going solving a puzzle wherein a number of 16 सपोज कीजिए एक चेस बोर्ड है, 16 बॉक्सेस हैं जिसमें आपको एक के बाद एक रूम्स में जाना है. एक रूम में ये वम्पस इज देयर, दिस डेमन इज देयर, एंड अदर रूम्स आर हैविंग सम पिट्स इन इट. ओके, एंड इफ यू फॉल इन अ पिट you lose the game, or if you fall in a if you just meet this demon, you again you lose the game. Okay, and there are certain constraints given to you how you can move about, and kya, there are certain signals coming whether the Wumpus is there in this particular room or not, or is there a pit in this room or not. So if there is a pit, there is a breeze flowing, so in the next room you can feel a breeze flowing, so you will not just move to that pit and fall down. And if it is a demon is there, there is a smell stink coming, so you understand. So accordingly you'll make a choice as to how to move to various different boxes or rooms accordingly, and then find gold somewhere. And once you get the goal, you come back the way you had gone, the path you had taken to go back to find the goal. You just come by that path to your destination, original destination. So this is a Wumpus world problem. Do look at it. It's quite an interesting thing. And moreover, there is a simulator also. There's this game also, this Wumpus world game, which is a simulator which helps you. You can play this game, in fact. And also one thing is that you also have an arrow wherein you can, if the this particular demon is there in that your line, the same horizontal or vertical direction in which you are facing, you can even kill this demon. So you are with that arrow. So this you can also go and see this simulator game. Do know about it, and just then you go and read your book. That book Russell की जो book है उसमें आप पढ़ सकते हैं इसके बारे में. So once you go through it, it is very easy to understand. At least you should know what it is. So, okay, it is. And what is that actually telling you? It's just telling you that there are so many constraints and there are certain moves that you make. So there are certain decisions that you take depending upon the constraints. And either you make a right decision or you make a wrong decision. So AI is all about making decisions, using the right kind of reasoning and logic. Okay, the propositional logic is the simplest form of logic where all statements are made up of propositions. A proposition is a declarative statement which is either true or false. So any proposition या तो true होगा या false होगा, there is a पता नहीं या मालूम नहीं type का answer नहीं रहेगा. So there is a true or false answer to it. Certain situations. Propositional logic is a simple language consisting of proposition symbols and connectives, and so these are the connectives that I use. So proposition symbols क्या है? P, Q, A, B कुछ भी आप लिख सकते हैं. Proposition symbols होंगे और ये connectives हैं. And है उसके लिए इस तरह से है, and, or, implies, if and only if, negation, uh, follows, and then you have this. This is also negation. Okay. So either a tilde sign or this sign you can use for negation. So these are certain connectives. So you can connect the two preposition symbols with the help of and, or, isn't it? So if you say P implies Q, means P, if P is true, then Q is also true. So such connectives you already have studied, in fact, so it should not be a big problem understanding this. The syntax of propositional logic defines the allowable conditions. So कुछ syntax है, किस तरह से आप लिखेंगे, कुछ symbols हैं, there are certain rules to it. Atomic sentence consists of a single prepositional symbol. Each, each such symbol stands for a preposition that can be true or false, and complex statements can be made by the connectives. So, example atomic statement है not A or A. This is a simple statement. If you want to make a complex statement, you can say A and B or C, and you make a complex statement like that. The proposition is something like that. Today is Sunday, or sun rises from the west, or so now if I say today is Sunday, definitely it is false, है ना? तो आंसर क्या होगा, ट्रू या फॉल्स में ही होगा. सन राइजेस फ्रॉम द वेस्ट, आंसर इज फॉल्स. 3 + 3 is 7, it is false. 5 is a prime number, it is true. So it would be resulting into true or false only. So if I say sun rises in the east, it is the first proposition P, and the second proposition is Q. And how do we really represent it is with the and connective. Okay. So there are logical connectives which make it compound or atomic. So ये जो हमने example लिखा, that is a compound statement. You have atomic preposition. Atomic preposition are the simple preposition, and it consists of single preposition symbols, and they are the sentences which must be either true or false. Compound prepositions are constructed by combining simple or atomic preposition using parentheses or logical connectors. इस तरह से यहाँ एग्जाम्पल दिया आपको. ठीक है, अगर सिर्फ यहाँ लिखा होता नॉट पी, सो इट वुड हैव बिकम अ एटॉमिक preposition. Logical connectives are used to connect two simpler prepositions or representing a single sentence logically. So there is something called a negation. A sentence has not P, which can be called as negation of P. Conjunction का मतलब है you are having an and over here. A sentence which has this connective is called a conjunction. For example, Rohan is intelligent and hardworking. It can be written as, okay, some Rohan is intelligent, Rohan is hardworking. So you can say P and Q. Okay. Disjunction, in this statement we have a this kind of connective, V connective, okay, such as P, and this connective Q is a disjunction where P and Q are prepositions. If I say something like Rita is a doctor or an engineer, either or, okay, so Rita is a doctor, so that is preposition P, and Rita is an engineer is preposition Q, and we can write it as P, this sign, disjunction sign, and Q. And if we have implication, means a sentence such as P arrow Q is called implication. If then, so implications are also known as if then rules. It can be represented as if it is raining, then the street is wet. So if P is it is raining and Q is street is wet, then we can represent it as if it is raining, it is P, it leads to Q, that is street is wet. All of this you must have already studied in your 10th, 12th standard or something, isn't it? Okay, so by direct conditional is the sentence such as double implies sign over here. We say that if I am breathing, then I am alive. So P is I am breathing, Q is I am alive. So it can be represented as if and only if I am breathing, I am alive. If and only if by conditional is. So these are various symbols, and the meanings for them are this: and, or, implies, if and only if, not. एंड क्या मतलब कंजंक्शन है, टेक्निकल टर्म जो यहाँ यूज कर रहे हैं हम. और का मतलब डिसजंक्शन है. इम्प्लाइज इम्प्लीकेशन बोल रहे हैं हम इसको. इफ एंड ओनली इफ को बाय कंडीशनल बोल रहे हैं यहाँ. जैसे नॉट होता है उसको नॉट को यहाँ नेगेशन बोल रहे हैं. द टर्म्स आर ओनली चेंजिंग ओवर हियर. Since there are only two possible true values, so a logical function with two argument needs a table with a 4 entries. So if you know that if there is only one variable, then how the truth table would look like? If the variable is a, the a can take what values? 0 and 1. So negation of a is 0 and 1. And if there are two variables, then you'll have to need four combinations are possible. इसी तरह से if there are 3 variables, 8 combinations are possible. So if I'm having over here A. So what are the various possibilities here? 1 1 1 0 0 1 0 1 0. ऐसे ट्रूथ टेबल तो आप बना ही चुके होंगे, तो आपको ये फर्क नहीं पड़ेगा कि और कैसे बनाते हैं. So this is an and. Okay, this is an and. 1 and 1 will lead to 1. Any other combination will lead to 0. So this we already know. So conjunction is an and, disjunction is an or. You can create this truth table. And implies. So here, if it is implies means uh, 1 and 1 is 0, 1 and 0 only when it is true. This is false. When this is false, this is true. 0 1 is 1, so just remember this. 0 1 is 1, 0 0 is 1, 1 1 is 1. When this is 1 and this is 0, then it is 0, because what is happening when A is 1, B is 0 here. So in this case only, A implies B is false or 0. Okay, we can just see how we can apply all of these. Okay, so you have various properties to these operators also. I'll just not go into detail of this. You already know most of it: commutative property, associative property, distributive property, the way we know in mathematics, na? De Morgan's law, double negation. Okay, commutative law मतलब क्या है? P and Q is equal to Q and P, है ना? या तो और के साथ भी वो use कर सकते हैं commutative law. So these are, we are going to use all of these properties of the operators to कंजंक्टिव नॉर्मल फॉर्म एंड डिसजंक्टिव नॉर्मल फॉर्म के जो क्वेश्चंस है हमारे, उनको सॉल्व करने के ये सभी प्रॉपर्टीज को आपको ध्यान रखना पड़ेगा. एसोसिएटिविटी क्या है कि आप इस P को या इस या तो आप P एंड Q को साथ में आपने रख दिया, या आपने Q और R को साथ में रख दिया, तो इट इज ओके. Either you write the term like this or like this, it is one and the same. Even if you have this, और के साथ भी सेम चीज बिहेवियर है, और एंड के साथ भी. डिस्ट्रीब्यूटिव मतलब यू आर जस्ट डिस्ट्रीब्यूटिंग P to Q as well as R. So that is distributive property. Okay, that implies for both disjunction and conjunction. When you have De Morgan's law, you know that we break the line, change the sign. This is what we say in De Morgan's law. So ये तो set theory में भी आप पढ़ चुके हैं कई बार. So when the negation moves in, the sign in between happens to change. And if there is a double negation, and you will, what happens? There is resulting to P only. So types of inference rules, that there are something like a modus ponens rule, which tells that modus ponens rule is one of the most important rules for inference. It states that if P and P gives you Q, P implies Q is true, then we can infer that Q will be true. Now this modus ponens rule is also called the law of detachment. Okay? Wherein the modus ponens rule is one of the most important rule for inference, but it states that if P and Q, P leads to Q is true, then P can infer that Q will also be true. It is written that अगर ये दोनों चीजें true हैं, तो it leads to Q. Okay. Whenever something in the knowledge base matches the pattern above the line, so जब भी कोई चीज, ये दोनों चीजें अगर true है, तो ये जो line के नीचे आपने लिखा होता है, ये भी true होगा. This is what is the modus ponens. Okay, if P leads to Q, implies Q, and P is true, then Q is also true. For example, if I'm sleepy, then I go to bed. Okay, so that can be written like this: if I am sleepy, I go to bed. If I second is P only, na, I am sleepy. Okay, P is what? I am sleepy, and Q is I will go to bed. The first case. Second is I am sleepy. So what is the inference? Conclusion क्या है? I go to bed. Okay, so that is what it is. Hence, we can say that if P leads to Q is true and P is also true, then Q will be true. There is something called the modus tollens, also called the law of denial. This rule states that if P leads to Q is true and negation of Q is true, then negation of P is also true. So it means that if something above the line is true, okay, then this is true. This is what is modus tollens. So if I am sleepy, then I go to bed. Okay. I do not go to bed. This is what is the negation of Q, isn't it? I do not go to bed. Then what? Then what? It infers that I am not sleepy. The inference is what? I am not sleepy. So this is what is modus stolen. So we'll be just using all of them to and there is something called a hypothetical syllogism, wherein it states that if P leads to R is true, whenever the rule states that if P leads to R is true, whenever P leads to Q is true and Q leads to R is true. Something that we learned in transitivity. Na? The P leads to Q and Q leads to R, then we can say that P leads to R. So this is some transitive relationship that you see in mathematics. Okay. So if P leads to Q and Q leads to R, we can say that P itself leads to R. So Q can be really has no role to play over here. So once you know this, a rule is there. Even if you do not know the value of Q, you can, if you know the value of R, P, then you can conclude for R. Okay. So whatever above the line, if this condition is true, then we will say that the whatever is given after the line is also true. If I am, it is something like if you have my home key, then you can unlock my home. If you have my home key, if you have my key, then you can just unlock my home. If you can unlock my home, then you can also take my money. Okay. So if you can unlock my home, you can also take money. इसका मतलब क्या है? Once you have the key, you can always take the this disjunctive syllogism. Rule states that if P or Q is true and not P is true, then Q will be true. Now, how can you prove all of this? You can make a truth table and just apply it and see. You can even prove that, okay, with the help of the truth tables. So today is Sunday or Monday. Okay, today is Sunday or Monday. So P is today is Sunday, Q is today is Monday. Then the statement today is not Sunday. Today is not Sunday. इसका मतलब क्या हुआ फिर? Monday होगा फिर. Okay. और की बात है ना, अगर P 1 है तो Q 0 हो चाहे 1 हो कोई फर्क नहीं पड़ता है ना, इस तरह से. So if P is 1 true, then this will also be true. If P and Q is true, then P or Q will also be true. So this we already know all of this, isn't it? You can just see the truth table and get to know. So all of this we have discussed out here. So these are certain rules that you can just apply to just convert when a certain combination of these rules are given to simpler rules. The limitation of propositional logic kya hai? If you want to represent something like for every or for some, it is not possible. So whatever combination that we know right now, we are not able to do for some or for every. So so you have something called a universal quantifier and existential quantifier. यहाँ से delete कर दिया शायद. Okay. So what is universal quantifier? Some statements telling about all the individuals or objects belonging to a certain set. तो उसके लिए आप फॉर ऑल यूज करते हैं, तो ये यूनिवर्सल क्वांटिफायर यूज कर सकते हैं. और जो एग्जिस्टेंशियल क्वांटिफायर कब आप यूज करते हैं? जब यू आर टॉकिंग अबाउट सम. The statement begins with something like for some, there is at least one. Then you use a existential quantifier. So wherever you have something like for all, example देख लेते हैं. The dog is an animal. A particular dog is a dog is an animal. A cat is an animal. The phrase is an animal क्या है? Predicate है. We use, how do we really write it? We use a capital letter to represent the predicate. So is an animal जो है उसके लिए हम एक capital letter use करेंगे. Okay, all small letters are used for objects of variables. So यहाँ objects dog हो गया या cat हो गया, तो उसके लिए हम small letter use करेंगे. So A is an animal. D is for a dog, and small c is for the animal. So this is the certain rules that we apply. So if there is only one predicate, then this is how you go about it. Suppose there are two, then how do we go about it? Suppose if you want to write something like x is greater than y, then and if you are using a g predicate for greater than, okay, तो आप कैसे लिखेंगे उसको? इस तरह से, है ना. G is having two predicates. So G in brackets X and Y. सब एक कोई रूल है, सपोज ऑल मेन आर मॉर्टल. ओके, मेन के लिए एम यूज किया है यहाँ हमने, जैसे कि यहाँ यूज करा था ना, is a animal, so that is a predicate. Is a animal is a predicate. So here men is a uh, is used by we are using capital M for it, and P we are using for mortals. Okay, so these are the two predicates over here. So what is it saying over here? All men are mortal. So उसके लिए आप क्या यूज करेंगे? For every. तो ये जो है ना, ये सिंबल यूज करेंगे, which is a universal qualifier, a quantifier. Okay, for X is for that particular person. Okay, for all men, uh, for that particular men, if it is a man, then the person is mortal, implies it is mortal. So this is how we write it. If we say some women are intelligent, so for women we are using W over here. So X is women, W is for the woman, I is for intelligent, IX denotes intelligent for that particular X. And for some, because it is not for all ना, for some लिख रहे हो ना आप, तो existent this we are using this existential qualifier over here, E. Okay, जब भी होगा, जब भी statements आपके आते हैं, something statements like everything, for every, for all, whenever that kind of statements come, you are going to use a universal qualifier. And if statement like for some, there exist, we are going to use existential qualifier. All of this that we have learned over here. So the first order logic consists of these two standard qualifiers. Okay, so अगर हम लिखें प्रॉपर्टीज क्या है इन क्वालिफायर्स की, फॉर एवरी एक्स एंड फॉर एवरी वाई, इज इट? फॉर एवरी एक्स, फॉर एवरी वाई इज सेम एज, किसी को भी आगे पीछे लिख दीजिए, कोई फर्क नहीं पड़ता. फॉर एवरी वाई, एवरी एक्स, वन एंड द सेम थिंग. फॉर सम एक्स, फॉर सम वाई इज सेम एज फॉर सम वाई, फॉर सम एक्स, same. Wow, you cannot, it doesn't matter if you just change their place. But if you look at, if you combine both of them, these do qualifiers, if you combine for every and for all, this if you combine, it doesn't remain the same. For every X, there exists a Y. Or for every Y, there exists an X. For every X, all Y के लिए बोल रहा है, यहाँ all Y, there exists an X. Okay, so this is not the same. For example, if we write this, what does it mean? If there is a person who loves everyone in the world, so there exists a person X, and Y is everyone in the world. There is a person who loves everyone in the world. So ये इसका order कैसे change हुआ है, ठीक है? So X is a person. There is a person who loves everyone in the world. And if it is something like this, if you brought this quantifier, universal quantifier before, what happens? Everyone in the world is loved by at least one person. This is how you can see the difference of the statement now. There is a person who loves everyone in the world. Everyone in the world is loved by at least one person. So this is how you could just not change the order. ओके हाँ, ये है कि फॉर एवरी की का अपोजिट ही है ना इस तरह से. तो अगर आपको ये क्वालिफायर यूज नहीं करना है तो इसको निगेट करके भी यूज कर सकते हैं आप. निगेट करके भी, फॉर सपोज ओवर हियर एवरीवन लाइक्स आइसक्रीम्स, you can also write it there like this: there is no one who doesn't like ice cream. The same statement can be written this way also. So universal quantifier की जगह पर existential quantifier को use किया, and you can see the difference how it is. So there is no one, there is no one who doesn't like, renegate कर दिया, doesn't like ice cream. Okay. So conjunctive normal forms are statements in Boolean logic, are conjunctions of clauses or clauses of disjunction. In other words, a statement is a series of ors connected by ands. For example, conjunctive normal form को अगर आप देखें तो A और B and C और D, तो क्या आपने कैसे combine कर रखा है? And से combine कर रखा है, ठीक है? तो उसको बोलते हैं conjunctive normal forms. जैसे कि 1, 2, 3. Three statements hai. Or how do have you combined it with this and? Okay, so this is what is a conjunctive normal form. What do you look at over here? It can be converted. Now this is a conjunctive. Now you can convert it and write it this way. Now this is not a conjunctive normal form. We are having an or and an and. So this is not a conjunctive normal form combination जो है. Okay. To convert a formula, so कई सारे questions आपको आएंगे जिसमें कि आपको convert करना पड़ेगा उसको conjunctive normal form या disjunctive normal forms में. तो कंजंक्टिव नॉर्मल फॉर्म्स क्या है कि हर एक स्टेटमेंट जो है वो किससे कंबाइंड है, एंड से कंबाइंड है. सो अगर आपको ये कन्वर्ट करना है, सपोज एफ और ये है और एंड यहाँ एंड है, तो इसको कन्वर्ट करने के लिए क्या करेंगे, दोनों के बीच में आपको ये एंड करना है. तो हमने क्या यूज किया, कौन सी प्रॉपर्टी को यूज किया यहाँ, डिस्ट्रीब्यूटिव प्रॉपर्टी. सो वी जस्ट बॉट दिस विद दिस जी एंड इसको फिर एच के साथ लेके आए, तो ये जो सिंबल है वो बीच में आ गया. So we have used the distributive property and converted. Now this ये red color में जो statement है ये हो गया conjunctive normal form का statement. इसी तरह से a implication of this statement, what are we doing is we are negating it and converting it. So you again using some law over here, and then again using the distributive law. Again using distributive law. Now what happens? These two clauses are there with a and in between. This becomes a conjunctive normal form. Every truth table can be written in either a conjunctive normal form or a disjunctive normal form. So if a conjunctive normal form है तो ये जो है ये conjunctive normal form है, और ये जो है वो disjunctive normal form है. You can see different statements are there which are combined with a or. In this, in CNF, everything is combined by a and. Okay. What have we learned here? The conjunctive normal forms and disjunctive normal forms. What are we wanting to do from it? This is the way in which knowledge is extracted and decisions are taken in an inference engine. So in the knowledge base, you have an inference engine wherein information is stored and will be utilized to make decisions. So there are two things like a forward chaining and backward chaining. Okay, questions like may come in the exam is differentiate between forward chaining and backward chaining. So forward chaining क्या है? Inference engine is the component of the intelligence system, an artificial intelligence system like an expert system, which applies logical rules to the knowledge base to infer new information from known facts. तो कुछ known facts as a proposition, कई सारे known facts are stored and you have to combine those facts and come to a decision, true or false के हिसाब से. The logical inference algorithms use forward and backward chaining approaches which require the knowledge base in the form of the first order definite clauses. So जिस तरह से हमने CNF और DNF देखा, उस तरह से knowledge predicates are there and you combine with the help of the rules that we studied. The definite clause grammar is a way of expressing grammar either for natural or formal languages in a logic programming language such as Prolog. So in the practical you must have already seen. So this example is there from Prolog. Inference engine commonly proceeds into two modes, forward chaining and backward chaining. So what is forward chaining? Forward chaining comes with known facts and iterates the process to find the new fact. Forward chaining means you collect facts and you come up with a new fact. Backward chaining is starts with the goal. You start from a goal and work backwards to determine the conditions, what conditions would be required to achieve the given goal. तो बैकवर्ड चेनिंग में गोल से शुरू करके पीछे की तरफ आप जाते हैं कि क्या क्या कंडीशंस हुए कि ये गोल तक पहुंचे, और फॉरवर्ड चेनिंग में यू आर कलेक्टिंग फैक्ट्स एंड इटरेटिव प्रोसेस के थ्रू नए फैक्ट्स को जान रहे हो. So you use something like a deductive inference rules here. Forward chaining. Suppose A is the fact and A implies B is there, then conclude from A and A implies B to B. So example over here, it is raining. A is what? A is it is raining. If it is raining, the street is wet. So what is B? B is that the street is wet. So if A is true and B is, and the second statement, the first statement is true that it is raining. The second statement is true that if it is raining, then the street is wet. Then what are we concluding? The street is wet. The abductive inference rules go by backward chaining. Concluded by this means if the street is wet, so we are starting from the goal. If the street is wet, that is what is known to you. Then now you're going behind to see the rules to find what are the various conditions that lead to this street is wet. If it is raining, the street is wet, then it is raining. Okay. Okay. So now to really understand what is forward chaining and backward chaining, we have an example in your books also, and quite common example about this American person who is selling some weapons to hostile nations. हाँ? तो इस तरह ये जो एग्जाम्पल है about it. Now this is given in these videos very nicely, but I'll not go about it. You can just just post these videos on the chat. You can just go and see what exactly is forward chaining and backward chaining. Okay, so I'll not repeat this for you. For this particular example of this American person who is selling weapons to hostile agents. So here it is just given an American robot. He's selling a missile. The weapon is missile. Okay, and there is an enemy of America. Okay, and this example is very well explained in these two videos, which you can look at.